This conference
Mona-
will now be recorded.
Monaco is actually a small country. It's a tiny country sharing its border with France. I mean, for all practical purposes, we can consider Monaco as part of France. Well, that is good, but why do we call this Monte Carlo simulation? Monte Carlo as a place is quite famous for gambling. You heard it right. Monte Carlo is quite famous for gambling. So, in gambling, I mean, the moment I talk about gambling, we have to talk about games. People play games, people gamble. Someone winning a game or someone losing a game is purely a matter of luck. Oh, in a casino, so long as the instruments and the devices are not loaded in the sense, so long as they are not bugged. Usually, whether you stand to win or you stand to lose is completely based on your luck. So, when we talk about luck, we essentially talk about random numbers. Whether I am going to win today or whether I'm going to lose in today's gambling game is just a matter of luck. And the easiest way to capture luck is by way of random numbers. So essentially, in Monte Carlo simulation, we are going to make use of random numbers. We are going to extensively make use of random numbers in order to model a system, in order to understand its behavior and to analyze its behavior. Now, just in case you get this question as to okay, maybe I'll come to this point little later. Let me not confuse you right away. So that's about simulation, and that's why it is called Monte Carlo simulation because we will make extensive use of random numbers. Now, take a look over here. What exactly is the purpose of simulation? We want to analyze a system. That's the purpose. We want to study the behavior of a system and we want to analyze its behavior. We want to understand how the system behaves under certain set of conditions. Well, you can always say, Ram, if that were to be true, then why not develop mathematical equations to study a system? Why not do analytical sort of techniques? Why not make use of analytical techniques to study a system? For example, we also have something called queuing systems in operations research. We, yeah,
Tom and Jerry
here is a
bonding.
here is a quick request. You have to keep your mute. You have to keep your mic on mute. Yeah, Tom and Jerry is definitely good, but not at this juncture. Okay. So I was talking about queuing systems. Now you can always say, Ram, we don't use simulation for queuing systems. We have mathematical models. We have m by m by 1 queue, m by m by 2 queue, infinite population, so on and so forth. Yes, you're absolutely right. We don't use simulation for simulating queuing systems because they are easy to model mathematically. It is as simple as that. Whenever you think some real world systems are actually easy to model mathematically with simple differential calculus or simple integral calculus, if you are in a position to mathematically model systems, then we don't need simulation. Essentially, simulation is used to model those systems that are really complex in nature. So when I say complex, okay, I'll show you some pictures of complex systems. But just a bit of information. How did simulation start? Everything, by the way, as many of you might be aware, operations research as a subject took its birth during Second World War. I mean, this subject was born out of a war. Monte Carlo simulation also took its birth during the Second World War. Project Manhattan. So Project Manhattan is all about dropping nuclear bombs, Little Boy and Fat Man. So when scientists developed nuclear bombs, they wanted to test it before actually using it on Japan. And in order to test it, one way of testing a nuclear bomb is to actually drop it and then see how exactly it is going to work. But at that point in time, scientists were not very sure if they can really control the after effects of a nuclear bomb. So rather than physically dropping the bomb, they wanted to develop computer models. They wanted to understand how exactly the nuclear fission and nuclear fusion reactions that take place inside a nuclear bomb. So they wanted to model it on a computer, and that's how Monte Carlo simulation came into existence. Well, needless to say, if something is not clear, or if you think I may have to repeat some of whatever I said, you're free to interrupt me anytime and then say, could you please repeat that point? I would be happy to repeat it for you. It's not that you have to essentially listen. I mean, as faculty of engineering colleges, I'm sure many of you might be pursuing your PhD, or many of you might have plans to pursue PhD in the near future. So you never know, you might want to use Monte Carlo simulation as one of the research tools in your thesis work. So wherever you think some more information could be useful, please, you're free to interrupt me then and there. I can clarify it. Then let's take a look at this. When actually to use simulation, this is something that I already told you. When you think it is extremely difficult to mathematically model problems, or when it is extremely difficult to analytically model problems, then the easiest resort is to go for simulation. That's one way. Second, cost consequence. When you are sure that testing something in real life might be prohibitively expensive, or might be dangerous and may lead to loss of life or loss of property, then people use simulation. For example, let's say India, DRDO, India builds one of the best missiles. One way to check the efficacy of this missile is to actually fire the missile and then see whether it hits the target or not. But you never know. If something goes wrong, the missile might just end in water, might just end in ocean. So we may not be able to fully understand what actually went right and what actually went wrong. So we build computer models so that we can understand. Similarly, testing something might lead to loss of property or loss of life. So for example, Airbus building a new prototype, let's say A3XX. Now they want to test it. One way of testing this new aircraft model is to actually take it through the cumulonimbus clouds and then see how exactly the aircraft performs under lightning, heavy thunderstorms, rains, etc. But the problem with that approach is if something goes wrong, everything just goes to waste. I mean, you may have to start the project again from scratch. So, and hence, these are the situations where modeling in a computer is far, far safer compared to actually testing a particular prototype. I'm not saying you should not test a prototype. Testing of a prototype happens only at the end. When you are about to actually launch the product, you want to check it twice or thrice before launching it. So that's when prototype testing happens at the end. But before that, it is always better to build computer models and then carry out whatever tests that we feel are appropriate. Take a look at this picture. So this is the picture that I was talking about earlier. As you can see in the first picture, I'm discussing pictures clockwise. In the first picture, an aircraft is actually passing through a wind tunnel. Now, as I said earlier, we may want to study what kind of forces exert on the aircraft. How does the aircraft withstand those forces? Do any of the parts of the aircraft subject themselves to a lot of stress, a lot of strain? So this is one advantage. Let's say you are designing a car, most of the mechanical engineers do. I would want to design the front portion of the car, including the windshield as well as the bonnet, in such a way that even if the car is traveling at 140 kilometers per hour, the air should just glide over it rather than obstructing the movement of the car. So that's another example. The same example in third. And then the aircraft example, something that I explained to you earlier. So the problem with all these examples is real-time testing is quite expensive. Real-time testing is actually difficult also, whereas modeling these problems using a computer is far, far easier. That's why we go for simulation. Now, applications of simulation, I mean, plenty. You name any field, I can give you an example. Particularly, Monte Carlo simulation in is quite used by banks as well as financial institutions. Obviously, apart from manufacturing and military systems, the field of finance uses Monte Carlo simulation quite a lot. Now, advantages of simulation, in a sense, you can carry out sensitivity analysis very, very easily. That is something that I'm going to show you when I actually take you through the Excel sheet. So when I say sensitivity analysis, we want to know, as a researcher, we want to study how exactly one variable affects the overall profit of the system. You want to study how this particular variable is contributing to the profit. What happens if we increase this variable by 50%? What happens if we decrease it by 50%? So this is something that is called sensitivity analysis. Studying or doing sensitivity analysis in Excel is far, far easier. And last, disadvantages of simulation. Sometimes I should have to say building a model is actually not very easy. It is an art. It comes by practice. And that is the only important disadvantage or limitation that I see with Monte Carlo simulation. And remember, you cannot blame the simulation model if you feed poor quality data. So the output of a simulation model pretty much depends on the quality of the inputs that you provide to the model. If you if you feed garbage, you can only expect garbage as the output. So that is something that I would want you to remember. Now, having given this background about Monte Carlo simulation, I'm planning to take you through at least 3 simulation examples. For this, I'm going to show you how to perform Monte Carlo simulation in Excel. I'm not going to do anything else. We are just going to perform Monte Carlo simulation in Excel. Now, for that, let me take a very, very simple example. There is an example on business planning. Now, I know many of you are faculty at engineering colleges, but that doesn't mean we are not students. I mean, a faculty continues to be a lifelong student. That's a philosophy that I personally believe in. So for learning, there is no right or wrong age. So have a pen and paper by your side. Sometimes it is easy for you to miss if at all I say something. Have a pen and paper by your side. If possible, you can have a computer by your side and then parallelly do simulation, just the way I do it. If you think, fine, sir, listening to you as well as doing it parallelly is a bit difficult, then in such cases, you may just note down whatever I show you on the Excel sheet and then practice it at a later point in time. Take a look at this. Here is a simple business problem that we use for simulation. Now, here is a marketing manager who is interested to launch a new product. Before launching the new product into the market, he would want to estimate how much profit is he likely to make. Now remember, simulation it has to be used under one important requirement that, okay, I'll put it up this way. If you are aware, there's something called assumptions in linear programming. One of the important assumptions of linear programming is certainty. We assume that everything goes as per the plan. But simulation, Monte Carlo simulation is a tool that is used under the context of risk, decision making under risk. We use Monte Carlo simulation when we have to take a decision under risk, particularly when we are dealing with probability distributions, we make use of Monte Carlo simulation. So take a look at this, please. Here is a business which has a fixed cost of 1,20,000. Now, all that the manager knows is the next year where they are planning to launch the product. The next year is likely to have three scenarios. It could be a slow market or an okay market or a hot market. You may want to take down the details. If it is a okay market, the manager is expected to sell at least 50,000 units at a selling price of 11 per unit. I'm also noting it down so that it is easy for me while explaining you on Excel. If it is a slow market, the company is expected to sell 50,000 units at an average selling price of 11 per unit. Whereas if it is an okay market, the company is likely to sell about 75,000 units at a unit price of 10 per unit. And finally, hot market, 1 lakh units at a unit price of $8. Now, given this information, there is one more thing that you may want to note down. Take a look at this. And most importantly, look at the first point. It is believed that the market will be slow, okay, or hot. There are equal chances of the market being slow, okay, or hot. So basically it says there is 33% chance that the market is going to be slow, 33% of okay, and 33% of hot. Now, last thing, another important piece of information is the unit cost. The unit cost varies anywhere from 5.5 to 7.5, with a most likely cost of 6.5. Given this information, see, remember, had there not been any probability distributions, this problem would have been a simple mathematical problem. I know what is the revenue, I know what is the cost, I know how many units am I selling, I can easily estimate what is the profit. But the problem in this particular case, the problem is difficult because we have brought in probability distributions into the picture. Because of probability distributions, now everything becomes expected. What is the expected profit? So for example, take a look at some of these questions. What is the maximum amount of money that is going to be lost if the situation is completely unfavorable? So here is a question that any manager would be interested to know before launching the product. In the worst case, how much money is the company going to lose? Similarly, with 50% probability, what is the expected profit? With 90% probability, what is the expected profit? Or in reverse, what is the probability that the company will make a profit of 1 lakh or above? Now, analytically, if I were to answer these questions, it's definitely not going to be easy. It may involve a considerable amount of probability, differential calculus, as well as integral calculus. But believe me, all these questions can be easily answered by running a Monte Carlo simulation model on Excel. So that is exactly what we are going to do now. Now, here is a quick break. So far, is it clear? Any questions from your side, please? You're free to let
Clear,
me
sir.
know if there are any questions.
Clear, sir. We can go forward.
Thank you. Thank you, Dr. Jitendra Kumar. I'm glad. I appreciate you could answer. So let me just open an Excel sheet first, and then let me share the screen with you. Excel. Yeah. Can you please confirm whether you're able to see the Excel sheet, everyone? or at least you can.
Yes, sir.
Yes, sir. Yes, sir.
Great.
Yes, sir.
Okay. Thank you. Yeah. Okay. Now, please see here. Here is the Excel sheet. It's very easy. I mean, don't think just because I'm opening up an Excel sheet, don't think I'm going to show you a lot of complex mathematical equations. I work for a business school. So in business, we don't want to bring in too much of mathematics because managers need not have to be good mathematicians. We focus more on results and how to go about implementing the results. So what is it that we are going to do in Monte Carlo simulation? Please pay attention. It's very, very easy. And for your reference, this session is being recorded as well. I'm sure Professor Sridhar might share this particular link with you at a later point in time, if at all you have any difficulty recollecting any of the details. So, okay, first thing, as I said, we are going to generate random numbers in Monte Carlo simulation. When I say generate random numbers, in Excel, how do we generate random numbers? Please see here. You have to use, here is a small formula. You have to use equal to RAND. So that is what the function for rand, and then open bracket, open and close those brackets. So by pressing enter, you can see that the model has generated, or Excel has generated 0.68. By pressing F9, the number changes to 0.89. I'm pressing F9 once again. It becomes 0.78. So as you keep pressing F9, the random number changes. There is absolutely nothing to worry about it. That's how Excel has been coded to generate random numbers.
Sir,
Sorry.
sir, can you please again repeat equal to? Can you again please repeat
Okay,
equal to
let me
R
show
and
you.
D?
Equal to, yeah. Let me type it in the chat window. You can see there. Equal to RAND, open and close brackets. So you have to use open bracket and then you have to use a close bracket. Okay, right?
Okay, okay, sir.
Now what are we going? Why am I talking about random numbers? Please see here. How many random numbers to be introduced here? In this example, we have to introduce as many random numbers as the number of unknowns. I'm repeating this point. We have to introduce as many random numbers as the number of unknowns. Now let me try helping you understand. So please see here. What we do not know is number of unknown, the first unknown that we are trying to answer. What is the nature of the market going to be? If I ask you the same question today, how exactly is the market going to be next year? You may say, well, there is so much of chance that it could be slow market, it could be okay, or it could be hot market. So this is an unknown. Once, may I please request you to mute your mics so that it doesn't bother everyone? Yeah. So once the nature of the market is known, based on the nature of the market, we can estimate the sales quantity. We also estimate the selling price. These are anyway given. But only thing that we do not know is what is the nature of the market. So we have to build a relationship between nature of the market and a random number. You have to actually map the random number with that of nature of a market. When I say mapping random number and nature of the market, look at this. We have slow market, okay market, hot market. Now, the question that I'm trying to answer is, if the random number generated is, as you can see, 0.6957, which market does it correspond to? Does it correspond to slow? Does it correspond to okay? Or does it correspond to hot? I mean, we have to build some kind of a relationship between the random number generated and nature of the market. So what are we going to do? First of all, let's try to understand. The description says there is equal probability of witnessing a slow, okay, and hot market, which means equal probability means 33.33% for slow market, 33.33% for okay market, and 33.33% for hot market approximately. I know it doesn't add up to 100%, but 99.99% is good enough. Now we may have to first build that relationship. So what am I going to do? Please see here. First, I'll just say random, and here is equal to rand. That's the function that I'm going to use, equal to rand. Enter. Now, what am I going to do is look at this. Cumulative 33.33% here, 66.66% here, 99.99% here. I just added up cumulatively. So what am I going to do is, if the random number generated is in between 0 and 0.33, I'm going to consider it as slow market. If the random number generated is in between 0.33 to 0.66, I will consider it as okay market. And from 0.66 to 1, I'm going to consider it as hot market. I'm repeating it. If the random number generated is in between 0 to 0.33, I'll take it as slow. 0.33 to 0.66, it is okay. And 0.66 to 0.99, it is hot market. So please see here. This is how we are going to construct the formula. So I will say quantity, because nature of the market tells us both the quantity as well as the price. So you always have to start with equal to. Now we can use if here. If this particular random number is less than or equal to 0.333, then look at the function. It says value if true, meaning how much quantity are we selling? If it is less than or equal to 0.33, it means it's a slow market. So we are expected to sell 50,000 units. Otherwise, we are going to use, if the statement is false, we are going to use again if. If the same random number D9 is less than or equal to let's say 667, that is, it comes to the second slab, then we are expected to sell 75,000 units. If the random number doesn't satisfy these two conditions, then the only condition that is left is it has to fall in the third price bracket. In that case, we can directly write we are likely to sell 1 lakh units. So I have to close the brackets correctly and then enter. Now you can see there. So please see here, as I keep pressing F9, I will show you the formula once again, but please pay attention. As I keep pressing F9, the random number changes, the quantity also changes. Please see here, 0.89. Just because the random number fell in the last slab, the quantity that we are selling is 1 lakh. F9, 0.48, that falls in the second slab, so the quantity also changes. Again, F9, 0.97, 0.26, automatically the quantity changes to 50,000. So here is the formula that we are going to use. And if you are not able to see, let me zoom it further. Yeah, please see here. So this is the formula that we are going to use. It is called nested if statement. Nested means a loop within a loop. That's called nested if statement. I'm going to share the Excel sheet with Professor Sridhar, who is the coordinator of the program. He will be definitely sharing this Excel sheet with you. So for the time being, please pay attention. You need not have to do it at your computer. It is going to be a bit of distraction. So please just follow whatever I'm trying to do here. Now, similarly, say selling price. The selling price, again, selling price and quantity both depend on the same random number. So what am I going to do is equal to if the random number generated is less than or equal to 0.33, I'm going to sell it at 11 per unit. Otherwise, if D9 is less than or equal to 0.667, we are going to sell it at 10, otherwise 8. These are the only three choices that are available. Now you can see by pressing F9 repeatedly, both quantity as well as selling price both keep changing. This is one way to check whether the way you modeled Excel sheet is indeed correct or not. Okay. Now, having mapped the random number as well as the market, the next thing is variable cost. The description says it varies anywhere from 5.5 to 7.5. The material cost varies anywhere from 5.5 to 7.5. So those who use Excel, they can very easily say, if I have to generate a random number between 5.5 and 7.5, there is a formula here. Please see here, rand between 5.5, 7.5. Now, as I keep pressing F9, you see what happens at the variable cost. Do you see any problem with the variable cost? Anyone? Can you answer? There is a small problem with the variable cost. What is it? I have been pressing F9. It is only returning
Showing
integer.
only it is showing only whole numbers.
Exactly, Dr. Deepti, correct. It is actually returning only integers. But in reality, cost need not always have to be integers. Stock market is all about floating numbers. Even 3 decimal points, 4 decimal points matter a lot. So what are we going to do? We are going to use a simple formula. Please see here. Just because the cost varies from 5.5 to 7.5, I'm going to make use of this formula. 5.5 plus the difference between 7.5 and 5.5 is 2. So 2 multiplied by rand. Now look at this formula. We know that the range of random number is 0 and 1. If rand is 0, the number will be 5.5. If I plug in 0 there. If rand is 1, the number will be 7.5. So I can easily generate random numbers between 5.5 and 7.5. Enter. Now you can see there it returns fractional values also. That's about variable cost. And then we have something called fixed cost. As the name suggests, it's a fixed cost which is 1,20,000. Now based on all this data, now comes the profit. The profit that this product is going to make depends on all of this data. So how much is the profit? This is equal to selling price multiplied by selling price multiplied by the quantity, or I shall say selling price minus the variable cost multiplied by the quantity, and then again minus the fixed cost. So this is the expression. Selling price minus variable cost multiplied by how much is the quantity that I am selling minus the fixed cost will give me the profit. As you can see, the profit is 1,18,405. Now let me press F9. Oh no, it is 1,08,590. Oh no, it is 44,509. Oh no, it is actually 1,12,000. You can see the variation now. By pressing F9, oh, in fact, the profit can at times go to negative also, minus 34,138. So the question is, which one should I choose? Should I choose a positive value? Should I choose a negative value? Should I choose a bigger value or should I choose a smaller value? That's the question that you are likely to ask me. Now, as you can see, each of these profits value is a possibility next year. So any of this can happen next year. Likewise, we may have thousands of combinations that could result next year. But you have to take a decision today. You cannot say, I will wait for next year to come and then I'll take a decision. That's not allowed. So given that there are so much of risks involved, there are so much of uncertainties involved, you have to take a decision. You have to decide whether to go ahead with this project or not. What is the probability of getting 1 lakh rupees or more? So these are the questions now we are going to answer using Monte Carlo simulation. So all that I did just now is just make one calculation. First I generated a random number. I mapped that random number to different markets. And then the only other random number that we are generating is the variable cost, because that is also uncertain. Hence, using these two random numbers, now we are going to estimate the profit. Now, this is what you are going to do. So please carefully see. Up to this, any questions, please? Is the procedure clear?
So you have said that it will be repeated for one more time. Can you repeat that one? The rand and all that selling price will be etc.
Okay, I will quickly do that. We are going to introduce as many random numbers. So you may have to mute yourself, please. You may have to introduce as many random numbers as the number of unknowns. In this problem, the unknowns are nature of market and then cost. These are the two unknowns in this particular problem. So we are going to use one random number here and the another random number here. So using these two random numbers, we are trying to estimate the profit. Profit is nothing but selling price minus variable cost multiplied by the quantity minus the fixed cost. You have to account for the fixed cost also. So this will give us the profit. Now, so when I say this is one scenario, one possible scenario for next year, there could be hundreds of scenarios like this, thousands of scenarios like this. What are we going to do now? Now, let us go back to the basic definition of probability. Can anyone take 30 seconds to tell me how do you define the word probability technically? What is the standard definition of probability?
Number of favorable outcomes. It's a ratio of number of favorable outcomes and the total number of outcomes, possible
Excellent.
outcomes.
Thank you. Thank you, Dr. Deepti. Amazing. Very good. Probability is a number of favorable outcomes to the total number of outcomes. Now, when I say what is 50% probability, if I ask you with 50% probability, what is the profit that I'm going to make? What I mean is if I generate 1,000 possible scenarios, out of these 1,000 scenarios, in at least 500 scenarios, that's what 50% means. In at least 500 scenarios, what is the minimum profit that I'm making? That is nothing but the profit with 50% probability. I'm repeating it. When someone asks you, what is 50% probability? What is the profit that I can make with 50% probability? What they mean is, out of 1,000 possible outcomes, I'm somehow going to generate 1,000 outcomes. Just don't worry about it. Out of those 1,000 outcomes, I'm going to see in at least 500 outcomes, what is the profit that I'm returning? I can return that profit as the answer. Similarly, if someone asks, what is the probability of getting a profit of 2 lakhs or more? What they mean is, out of 1,000 scenarios, in how many scenarios did you actually get a profit of 2 lakh or more? That is what they are asking. Am I correct? So that is something that we are going to do now. We are going to make use of this basic probability definition to generate all possible outcomes. You might say, Ram, you're kidding. Because you're using random numbers, there might be infinite possibilities. I agree. It may not be theoretically possible for me to generate infinite possibilities. But thankfully, literature has a guideline. I will show you. Let me first show you and then talk about probabilities. So let me just move these things away. What am I going to do now is, this is the value that we are interested to simulate. So keep this in mind. We are interested to simulate the profit value. So let's say I want to generate 3,000 outcomes, 3,000 possible outcomes. It does not mean you have to keep pressing F9 3,000 times. Well, that is very tedious and a laborious process. There has to be a better way of doing it. So how are we going to do it? Please carefully see here. We want to generate 3,000. I know some of you are likely to ask me, why only 3,000? Why not 4,000 or why not 2,000? I will come to that question little later, but please be patient until then. As you can see, I'm just dragging my mouse, dragging the Excel sheet so that the number becomes 3000. So I'm going to generate 3000 possible outcomes. That's why I'm doing this. Now, okay, I generated actually fewer more. Yeah, here is 3000. And then now, though, so what are we going to do is, this is the value that we are interested to simulate. So equal to whichever profit value. Now, don't think we just need to drag and drop. If you simply drag and drop, you will not get the answer. Here is the standard procedure. So select these two columns, shift and down arrow. Everything gets selected. I'm repeating it. Shift and down arrow. All the three buttons have to be pressed together. Now go to data. In data, there is something called what if analysis. In what if analysis, click on data table. So you'll get a small dialog box like this. You might be seeing something on your screen as well. Don't type anything in the row input cell. In the column input cell, just choose a blank cell anywhere on the Excel sheet. Just any blank cell on the Excel sheet and then say OK. And now you see there, you have 3000 possible outcomes. I know you may not have got this, so let me repeat this once again. Shift and down arrow. I'm repeating the whole thing once again. Whichever value you want to simulate, so you are going to first make this, enter. You are going to select both the columns, shift and down arrow, shift and down arrow. Both the columns till the 3000 rows will get selected. You're going to go to data. In the data tab, there is something called what if analysis. In the what if analysis, please click on data table. You'll get a small dialog box. In the data table, don't type anything in the row input cell. The column input cell, just choose a blank column somewhere and then say OK. So by doing so, you're actually generating 3000 simulated values. So next year is definitely going to be one of these 3000. You might ask me, how did you get that 3000? Again, you have to be a little patient. I'll give you the answer. Now, first of all, having generated these 3000 values, we may now have to find out some important analysis. Average profit. How much is the average profit? Look at this. This is equal to average of, we use the average function, M9 to M3000 values. So 3008, it will select all the 3000 values. M9 to M3008. Is that correct? M3008, enter. Let me just check it. Is it 3008 or 3009? Yeah, 3008, that's correct. Now, the average profit that we are likely to get from this product is 91,401. You might say, how do you know? Let me press F9. See, I have been pressing F9. Look at the average profit value. The average value is hovering around 91,000, 92, 93,000. Earlier, in this case, there was a lot of variation, but now the variation has come down. The average profit is hovering around 92, 93,000. Well, someone can say, Ram, even this variation is too huge. Sometimes it is showing 89,000 and sometimes it is showing 94,000. What do I do? The answer is very simple. If you think the variable of interest, I mean, if you are choosing average profit in order to decide whether to launch this product or not, if you think that's the basis on which you are going to take a decision, and if you think the deviation has been huge, the model is telling you that 3000 simulations is not sufficient, is insufficient. So essentially what you're supposed to do is make that 3000, 5000 or 6000. Worst case, make it 10,000. Nothing will happen to your computer. It may just become slow so long as you keep the Excel sheet open, but nothing else will happen. So then you take the average of 10,000 results. Now do you understand? This 3000 or 4000 is just a matter of judgment, trial and error. If you think the variable of interest, now I showed you the average profit. For example, I can show you the median 50 percentile. So please see here, we are generating the median. M9 to M3008. Look at this. The median profit is close to about 1,99,308. Let us say the decision maker in this context is going to decide whether to launch this product or not based on the median value. I'm pressing F9. Look at F9. Look at the median value. The median value is pretty much hovering around 1 lakh. For all practical purposes, one can say the median profit that this product is going to return is 1 lakh. So now you can decide whether to launch this product or not. And as you can see, there is not much of variation. 99,000, 1 lakh, 99,000, 1 lakh. It's not much of variation. So it means this simulation, the number of simulations is good enough. So to help you understand what is this good enough, in mechanical engineering, we use this concept of thermal equilibrium. Well, I being a mechanical engineer, I can easily connect thermal equilibrium. So equilibrium is a state at which no more changes happen. So that's called pretty much 3000 simulations is considered to be equilibrium. Any questions so far? I did not complete the presentation yet. We have a lot more to do on the same example. Okay, now,
Yeah,
just because that. Sorry, Dr. Jitendra.
you can continue, sir.
Okay, thank
Okay,
you.
till now.
Now, okay, good. Now, you might say, Ram, are these the only two measures of performance? Do we need to consider only mean and median? Can't you teach us something else? Absolutely, how much ever you want. Okay, now let me show you. Worst case profit. Worst case profit. What does that mean? In the worst case, how much profit am I likely to get? So, which is nothing but 0th percentile. Worst case profit is nothing but 0th percentile. I'm sure you know the difference between percentile and percentage. So we are talking about worst case profit. How much is the worst case profit? See, here is the formula. You may have to remember this formula. There is nothing that I can do about it. Equal to percentile.inc. So it returns the percentile value. Percentile.inc. The array is M9 to M3008. We are interested in 0th percentile. So we are going to write 0. Now look at it. Minus 69,665. Take a look at the formula here. 0th percentile is nothing but all the 100% of values are above this number. What is that number? We are interested to know all these values are above a certain number. What is that number? It is nothing but 0th percentile. In this case, the 0th percentile is minus 69,817. That means worst case, if everything goes bad. You might say, Ram, how do you know 69,817? By pressing F9, let's see what happens. Look at that value. By pressing F9, what is happening? The first two digits, at least minus 69, is remaining the same. So which means 3000 simulations is good enough to arrive at a conclusion. As you can see, even in the worst case, we are not going to lose more than $70,000 in this particular case. Similarly, let me show you some more formulas. Let's say with 80% confidence, I want to know how much profit. 80% confidence. How much profit will this project give me? So equal to percentile.inc M9 to M3008, comma. If you want to know the 80% confidence value or 80% probability value, not confidence, 80% probability, I want to go know the 20th percentile. So this is 0.2. So please see here, the answer is 53,205. The way you interpret that 80% probability is, let me just 53,205. What does that mean? Among these 3,000 values, close to 80% of the values are above 49,519. I'm repeating it. Out of these 3,000 values, close to 80% of the values are above 50,000 rupees. So at least we can say that with 80% confidence, I'm likely to get a profit of 50,000 rupees. Then some more cases. A profit of, let's say, 1.25 lakhs. How much probability, with what probability I can say I'll get a profit of 1.25 lakhs or more? So essentially what we are asking Excel is, out of these 3,000 values, tell me how many values are greater than or equal to 1.25. For this, the simple formula is 1 minus percent rank dot inc. The array is again the same, M9 to M3008. The value 1.25 lakhs, 1,25,000. So this is the formula. Don't worry too much about the formula. Once I share the Excel sheet, then you can easily remember. Press enter. The reason why it is taking some time is every time you press a key, 3,000 simulations run in the background. So your computer is likely to become slow, but that's normal. So look at this. I'm pressing F9 continuously. For 1.25 lakhs, you can see that 31%, close to about 31%, and the value pretty much remains the same. Even though I have been pressing F9 continuously, the probability value is 0.31. So which means there is 31% chance that I can expect a profit of 1.25 lakhs or more from this particular project. So there are two formulae which are part and parcel of Excel. One is percentile.inc, the other one is percentrank.inc. So these two formula are specifically applicable for arrays. While I share the Excel sheet with you, you can just take a closer look at that particular formula. So this
Sir,
is,
1 second.
yeah,
I wanted to ask, like, this particular formula percentrank.inc, it is asking for significance as well, but you have not
yes,
typed it, and it is giving you result. And in
correct.
my yeah,
Yeah.
so it is
So
asking
in
for
this
significance level as well.
in this case, I'm just leaving it to a default value, which is a worst case scenario.
All right. Thanks a lot.
Thank you. Okay, so you can see that we are likely to make 31.2% probability. With 31.2% probability, we can make 1.25 lakhs. So this is the first level of analysis that can be carried out using Monte Carlo simulation. The reason again, Monte Carlo means gambling, gambling means random numbers, and here we use random numbers to model all possible outcomes. And based on all possible outcomes, we try to draw some sort of inferences or conclusions. That's why it is called Monte Carlo simulation. If you don't have any questions up until now, I will show you what is the second level of analysis that you can do in the same example. Open to questions, please. Well, I have my headphones, don't worry. It's not that I have my headphones on. So even if you speak, I can hear. I don't want to sit on a chair for long. Sitting is the new smoking. Okay, if there are no questions, let me show you the second level of
I have a
analysis that,
question, sir. I have a question.
please.
Like, with the help of what if analysis, right, we can get to know the worst scenario and best scenario. So,
Mm,
is it different from this particular exercise which we have done it right now?
Let me show you the second level of analysis.
Okay, okay.
Okay, now you might want to know, okay, here is a first second level analysis. Let's say uh, the manager thinks he's a very good negotiator. Okay, so he can go and negotiate shrewdly with people, and he can actually help in cutting down costs. Now you want to know, okay, let's take the median profit. we will take this as our variable of interest. Here is the variable of interest. The median is what I'm considering as the variable of interest, which means we are going to further all our analysis based on this particular value. Now, as of now, the median value is about 98,000. Now, let's say instead of the cost varying from 5.5 to 7.5, what if this manager goes and negotiates very well with his supplier and then says, please give me a discount of at least 50 cents. So rather than 5.5 to 7.5, I would want that to be 5.5 to 7. Is it really going to have any effect on the variable of interest? For that, what we are going to do is, look at this. This is the formula 5.5 plus 2 into rand. Instead of 2, I'm going to make it 1.5 into rand. Now you can see enter. I'm pressing F9 repeatedly. So please see there, look at the median value. The earlier median value was only 98,000 with a savings of 0.5 cents, with a savings of 50 cents. The median has jumped from 98,000 all the way till 1,17,000. So you can actually quantify your negotiating skills to your management. You can go and tell your boss that because of my negotiation skill, we could save the company so much amount. This is one level. Okay, let me show you something else. I'll just make it 2 once again. Now, let's take something else. The selling price. What if the marketing department, I mean the sales and marketing people, what if they feel, well, 11, 10 and 8 are actually quite low. They believe that even if you increase the price, let's say by $1, people are ready to buy the products in the market. So they are making a strong case for increasing the price by $1. Let us see what is the final effect that this increase of $1 on price is going to have on the median value. Please see there, I'm just going to change 11 to 12 and then 10 to 11 and then 8 to 9. I'm just pressing F9. You can see there, look at that. An increase of $1 in profit, and look at your median, 1,68,000, close to a difference of 70,000. So this is the kind of analysis that managers are interested. This is the kind of analysis people are interested to pursue. Rather than simply giving me an answer, you should be able to give me all what if conditions. What if my profit, I reduce my profit margin? What if I increase my profit margin? What if I'm able to sell 500 units more? How much does it contribute to my profit? So all of this analysis is called what if analysis, also called as sensitivity analysis. We are just not interested to know only worst case and best case. Even 10th class students can do that. But as business school faculty, as industrial engineering faculty, as mechanical engineering faculty, you have to do a step further. We have to go a step further. You have to teach operations management from purely an application perspective. Tomorrow, our students are going to become managers. And as managers, they have to carry out all this analysis. So this is the kind of analysis that people can play around with. And this is the second level of analysis that I was talking about. With this, I'm done with the first example. If there are any questions, I'll be happy to answer them. Otherwise, I'll quickly take you through a next example, a second example, a small example, but worth listening to. Questions, please.
Only thing is that you will be sharing your Excel sheet to us for all these formulas so that we can exercise on that.
Definitely, yes, Jitendra. I'm going to share it with Professor Sridhar.
Okay, sir. Then till now it's okay. Getting.
I will share the Excel sheet as well as I'm going to share.
वाउचर अगर अभी देंगे कुछ, मैं बोलूंगा कि बना के दे दीजिए अपने साइड से, एक बिल बना दीजिए.
Rituraj, you have to please mute yourself. I mean, we are actually in a video conference.
मैं वही बोलता हूं सर, एक कंप्यूटर जनरेटेड ही दे दीजिए सर, सिंपल सा ये करके और फिर सील साइन कर दीजिएगा, चलिए हम लोग उससे और कुछ जरूरत पड़ेगी.
Yeah, whoever is talking, can you please?
और सर्टिफिकेट भी आएगा तो कोई दिक्कत ही नहीं है, सामने सर्टिफिकेट तो लगेगा ही, तो लगेगा. ठीक है सर, हाँ वो एक बार बात करने देता हूँ सर, पहले बात.
You may have to mute, please. You may have to mute, please. There's so much of disturbance, crosstalk. Yeah, come on, we are in a session. You just can't keep talking like this. Thank you at least for that. Oh God, again.
पता नहीं वो वास्तु वाले भी आए थे, तो वो नीचे वाले जैसे ये घर है ना सर, ये नीचे वाले 3 लोग पॉजिटिव आ गए, एक ही मतलब घर के 3 लोग 4 लोग थे, तो उसकी जो बेटी है एक वो बस नहीं है, बाकी
whoever is talking, can you please stop?
तो लिए मोटर का यूज करते हैं, रे करते हैं, वही है मैं नाना.
Coordinator, can you please? Okay, thank you. Fine. Now let's go to a second example. Yeah, Rituraj, I mean others as well. I'm going to share the Excel sheet as well as the PowerPoint presentation. So don't worry about it. Now I'll close this Excel sheet because let me save this Excel sheet first. This PC desktop, I will say ATAL program first, ATAL 1. Okay. The reason why I'm closing this Excel sheet is if I keep it open, it is going to run 3000 simulations again in the background. It will eat away all my computer RAM. So I'm not going to do that. Here is a second example. We are interested to find the value of pi. Pi. We know that pi is 22/7. So using Monte Carlo simulation, I'm going to show you how to compute the value of pi using random numbers. Now, for this, we are going to conduct a small experiment called rice grain experiment. Take a look at the chat window. The name of the experiment is rice grain experiment. Now, what is this rice grain experiment? Think about this. Imagine there is a circle, okay, and this circle is inscribed in a square. So there is a circle, and then I'm going to inscribe that circle in a square. I'm going to divide the circle into 4 components. So across the 4, I'm going to divide it equally into 4 components. Now just take one of the components. So how does it look like? Typically it looks like this. Let me try showing you this. Let me show you a picture. Maybe it will help me if I use a PowerPoint presentation itself. Okay, let me do that. New slide. So let me show you what exactly I mean by that. Insert, and then here is the shape that I'm talking about. Let's say, so this is the square, and here is a circle. We are going to insert a circle. Now I know it may not look like a circle, but please bear with it. Okay, so here is a circle. Now I'm going to divide it into 4 components. So we are going to focus only on one component. Okay, so typically how does that look like? Let me just move this. So if I take only one component, this is how it is going to look like. So here is one portion of it, and then we are going to have an arc. So typically this is going to be like this. No, it doesn't work. Okay, doesn't matter, fine, we will leave it there. So I'll presume that you know what I mean. I'm just going to keep an arc over there. Okay, so let me change it. Fine. So what we are going to do now in this rice grain experiment is I'm going to take a lot of rice grains and I'm going to keep this small portion, this 1/4 portion on the floor. I'm going to start pouring a lot of rice grains over it. So while the rice grains are poured, I shall make sure that there is a leveler. There is a leveler which actually ensures that these rice grains do not form a cone. The leveler will make sure that the rice grains are uniformly distributed over the surface. Okay, so what I mean to say is, let me show you, maybe that picture will help. Just give me a second. I'll just show you what exactly I mean. So here is the square, and then format shape. I don't know, shape, fill, shape, or yeah. Okay, let's. There is no shape here, and then insert. So let's use an arc. Let me use this arc. So this is how the circle might look like, right? So typically it might be like this. So this is how it is going to look like. That's the arc. Now text. So let me just quickly do size and position. So let me increase the width of this. And then, yeah, this should be good enough. Okay, so you can see, so we are going to start pouring rice grains over the surface. As the rice grains are formed, there is a leveler which actually ensures that the rice grains are uniformly distributed. Now what happens is, what we are going to do is, I'm going to count the number of rice grains that fell on and inside the circle divided by the total number of rice grains. I'm repeating it. Number of rice grains that fell on the perimeter of the circle as well as inside the circle divided by the total number of rice grains. This ratio, let's compute that particular ratio. Let me show you here. So first of all, so this is what I'm going to do. Area of the circle divided by area of the square. This is equal to pi r square by 4. So let's say, let me insert, okay, pi multiplied by r to the power 2 divided by 4, pi r square by 4 divided by, where if we take the area of the square, that is length and breadth as 1, it is only going to be 1. So this is nothing but area of the circle to area of the square. This is nothing but, let me write it here. If we assume the radius of the circle to be 1 unit, then r will become 1. Sorry, let me correct it. R becomes 1. So the area of that particular portion of the circle will be pi by 4, pi divided by 4 divided by area of the square. Area of the square is 1. This ratio is going to be made equal to number of rice grains that fell inside the circle divided by total number of rice grains. This is what we are going to simulate now. Please see here, pi by 4 tells us the area of 1/4 of the circle divided by the total area, which is 1, length multiplied by breadth. This must be equal to number of rice grains that fell inside the circle and to the total number of rice grains. This is the rice grain experiment. Now, how do we carry this experiment? For this, let me show you a procedure. You have to tell me what exactly is the logic. Okay, X, Y, please carefully observe first. After that, you can tell me what is the logic behind my experimentation. This is equal to rand. Here I'm generating one random number. Again, I'm generating another random number for Y. And then I will say X square plus Y square, which is nothing but this particular value to the power of 2 plus this particular value to the power of 2. And now I'll put a condition. And that condition is if this particular value is less than or equal to 1, I'm going to return 1, otherwise I'm going to return 0. I'm repeating it. If x square plus y square is less than or equal to 1, the function will return 1, otherwise it will return 0. So let's see what happens. Now I'm going to simulate this particular value. So for this, I'm going to generate, let's say again, 3000 simulations. So let me quickly show you to 3000 simulations. You know by now how to get this done. So I'm not going to repeat whatever I mentioned earlier. I know I'm being a little quick, but please pardon me. In the interest of time, obviously I cannot eat your lunch break. Everyone's time is equally important. Okay, here is 3000. Now, the value that I am interested to simulate is this conditional value, whether x square plus y square is less than or equal to 1 or not. So I'm going to put a equal to F13. As usual, shift and down arrow, data, what if analysis, data table, column input cell, a blank cell, and then say OK. Now you can see Excel as usual has generated 3000 simulations. Now, rather than taking mean or median, I'm going to take sum because I want to count the number of rice grains. This is nothing but sum of I12 to, sorry, let me put it up, I12 to I3011. So approximately 2378. By pressing F9, you can see there 2364, 2363, 2337. So it keeps changing. Okay, 2342, 2344, etc. Which means obviously 3000 simulations is not sufficient. Well, before I show you how to compute the pi value, can anyone tell me what is the logic behind this? Why did I generate a random number for x? Why did I generate a random number for y? And what is the purpose of computing x square plus y square and seeing whether it is less than or equal to 1 or not? Anyone, please? I will do that, Nirav. Just give me a second. I'll repeat the simulation. Just give me a second. But can you try answering my question? What is the purpose of finding x square plus y square? X is a random number, y is a random number.
The it's actually the formula for circle, right? X square plus y square is equal to r square, and we have
Okay.
taken radius 1, so it should be at least 1. X square plus y square should be at least equal to 1. So if it is
Hmm.
less than or equal to 1, we are taking the value as 1, and if it
Hmm.
is above that, then that is not the case actually. So that is why we are taking it as 0.
Okay, great. Thank you. So think about it. When you drop a rice grain on the floor, whether the rice grain fell inside the circle or outside the circle, the only way to find it out is if x square plus y square is less than or equal to 1, it means the rice grain fell inside the circle. If the rice grain fell outside the circle, then x square plus y square is going to be more than 1. So basically to find out how many rice grains fell inside the circle and how many rice grains fell outside the circle, I'm just using that condition. And Nirav, you wanted me to repeat it. So please see, Nirav. So this is the value that we are going to simulate, the condition value, okay, equal to this condition, and shift and down arrow. That's the procedure. Shift and down arrow, go to data, what if analysis. In what if analysis, there is data table, and in column input cell, you should not type anything in row input cell. In column input cell, I'm going to choose a blank column anywhere in the Excel sheet and then say OK. Now you can see that it would have generated 3000 simulations. Okay, Nirav? Now I'm going to count the total number of rice grains that fell inside. So as you can see, by pressing F9, 2345 or 2350. So what it means is Out of 3,000 rice grains that I dropped on the floor, 2,350 rice grains actually fell inside or on the circle, which is nothing but, so if I have to go by explanation, please see here, pi divided by 4 is equal to number of rice grains fell inside the circle. Please look at your chat window. Inside the circle divided by total number of rice grains. That's our formula. We don't know the value of pi yet. So pi divided by 4 is equal to, I'll approximately take it as 2,350. Okay. So actually the number keeps changing. So I'll approximately take it as 2,350 divided by 3,000. So which is nothing but pi is equal to 4 multiplied by 2,350 divided by 3,000. Let me check what is that value. So this is equal to 4 multiplied by 2,350 divided by 3,000. Okay, the value is pi is equal to 3.1333. Now you can see there the actual value of pi is 22 by 7, which is 3.14. And using simulation, we could actually come very, very close to the actual pi value. So this is how even things related to engineering can also be simulated and obtained. With this, I'm done with both the examples that I wanted to cover as part of the presentation. Just for your information purpose, as I told in the beginning, Monte Carlo simulation is predominantly used in finance, particularly SIP, valuation of systematic investment plans. In the interest of time, I'm not in a position to take up that example now. It will easily take another 45 minutes or 1 hour. Nevertheless, while sharing the material with Professor Sridhar, I'll try to share that investment file also. You can just take a look at it, and if you have any difficulty in understanding it, you can always reach out to me. Professor Sridhar has my email ID, and if needed, you can call me on my mobile phone also. I would not mind. With this, I'm going to rest my case for Monte Carlo simulation. I would be happy to take if there are any questions. I will, Dr. Deepti. I'm going to share that portfolio problem also.
Any queries from the
Any other-
participant side?
Thank you, sir, for your nice presentation. By sharing your things, only we will be getting the answers. Then we can contact you any doubts in your mail ID.
Definitely. Sure, definitely not a problem. Please feel free to write to me. I absolutely do not have any problem in responding to your emails. At the end of the day, we are all birds of same
Thank
feather.
you.
We are all teachers.
Thank you.
So I think, sir, there are no more queries from the participant side. So from the
Okay.
organizer's end, I would like to thank you for such a wonderful session, sir. This is quite informative, and you provided such a exposure for the simulation method that I all would have learned a lot many things from you. We often attend training sessions which are mostly the examples are given through the help of presentations, PowerPoint presentations only. But you have superbly used the Excel sheet to demonstrate how the simulation can be done effectively with the help of this Excel sheet. It was really a wonderful experience to attend the session by you, sir. And we expect that in near future also, if any such session will be conducted from our end, we will invite you so that all the participants will be benefited. So thank you very much again, sir, and have a nice day. So participants, the next session will start from 3 p.m. So till then, there is a break. Thank you very much, sir, again. And
Thank
sir
you.
has
It was
already said that he will be sharing
workshop.
the sir will be sharing the Excel sheets and the PPTs, and we will be sharing it with the participants so that they will read it, they will have it, and then they can revise and repeat the things to understand in a better manner. Okay, thank you again, sir.
Thank you very much. Thank you. It
Thank
was
you.
Thank you
pleasure
so much, sir.
to be part of this workshop. Thank you. Bye bye. Take care.
Thank you very much, sir. Okay. Have a nice day, everybody. Have a nice day, sir.
Thank you, sir.